everybody. We're going to go right into What's the Move Part 2. Today's move is subtraction. With addition, we had one action, which was put together. But with subtraction, we have three. So we're going to go over those three actions and then get into the different ways that you can show subtraction. Our subtraction problem for the day is 486 minus 259. The first action that we're going to talk about is take away. You can show takeaway using different models such as a strip diagram or other pictorial models. So let's get into them. Okay, we need to know our parts of a subtraction problem. Our first part would be our total, which is 486. This box represents 486. To show my action or my move of taking away and what I am taking away, you would just make a part within that box to show. In this case, we're going to be taking away 259. Make a part, place 259. Now with strip diagrams, the way that we actually show taking away is we actually show that that is being removed from the picture. So we show it going out or being taken away from the picture. And then from there, what's left over would be what we're looking for, what our question is asking for, or the difference between these two numbers. Okay, here's another way of showing that. Could show it also using a different shape like a circle, where again our whole will be represented by this circle, 486. And we will use an arrow to show that it's going away from the total. And then the number that's being taken away, or what exactly is being taken away, is 259. So there will be 259 less. So those are your two ways that you could show taking away with a model. Now our next move is comparing. We know comparing being used with symbols such as greater than, less than, or equal to. But when we want an exact amount in a comparison, like how much less or exactly how much more something is than something else, we will use this particular model. So as you can see, we have two boxes that are two different sizes. Of course, our bigger number will go inside the bigger box. In this case, that will be 486. Our smaller number will be in the smaller box, 259. To show that you are comparing these two, we are going to basically add on a dotted portion because we're looking for how much more is 486 than 259. So in order to find that, we're going to make these two boxes appear to be equal. You would also see this in scenarios that say like how much longer one thing is than another, how much faster one animal is than another, or how much less money does one person have than another person. And so we would draw a line to represent what we want them to be compared equally. But as we can see, one is more, one is less. So to find how much more or less, or that empty space, we would have to subtract. This will be what we're looking for. How many more does it take to get from this 259 all the way to the equivalent amount of 486? This would be a comparison scenario. The third action or move is when you're looking for a missing part to something. Kind of like a part whole scenario. Where 486, of course, will be our total, our whole. And remember, you can put the whole at the top or the bottom. But for this case, since I've had it on the top, I'm going to put it on the bottom. Okay, we know one part of this is 259. So again, I'll make that part, I'll represent that part by writing it within the other half of the part whole box. We use subtraction to identify that missing part. Now, something very interesting about this particular model is that when you write a number sentence for it, it's not always shown as subtraction. Sometimes we may see it look like this. We know there's 259. We also know that there is a part missing. But we know when we combine those two parts, we get our whole or our total of 486. Does this still represent the same picture? Yes, it does. Because there's a part that we know, there's a missing part, and then we have our whole or our total of 486. So yes, even addition number sentences, depending on how they are arranged, they can also represent subtraction problems. So those are our 3 actions. Now we're going to go into the different ways that we can show these actions, the ways that we can find the difference between 486 and 259. Now remember, just like last time, I'm going to save the algorithm for last because this is what we know. The students are introduced to all of these other ways, and the algorithm is the last thing. So I'm going to start with base 10. Base 10 looks a little different when we subtract, and I find this way to be more effective to help students see when they need to regroup. What I did here is I created the 486 into base 10 pieces. So there are 4 hundreds, 8 tens, and 6 ones. And then what I did, instead of making pictures again, I just wrote the other number that we're subtracting, 259, I wrote them as digits. This way, as the students begin subtracting, they can actually see when it is needed to regroup. For example, if we look in the ones place, because that's where we start subtracting, we notice that there are 6 ones, but I need to take away 9. So this is a great way for children to see that, hey, I don't have enough to take away 9, so I'm going to have to do some regrouping. I'm going to have to, as they would say, borrow from the tens place. So to show that you are regrouping, you're basically going to break a 10 apart. That 10 is going to be broken and decomposed into 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then once your regrouping is done, then you ask again. Now I have these 6 and 10 more, so that's 16. Do I have enough to take away 9 now? And the answer to that is yes. So let's go ahead and take away 9. I just take away by using one little slash through. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, however many are remaining that don't have a slash through, that's going to be what I need to put for the ones place. So that's going to be 1, 2, 3, 4, 5, 6, 7. So I have 7 in the ones place. Okay, now that I have that, I can go into the tens. Okay, I have now 1, 2, 3, 4, 5, 6, 7 tens, and I need to take away 5. Do I have enough to take away 5? And in this case, yes, I do. So there isn't regrouping necessary here. So I'm going to take away 5. 1, 2, 3, 4, 5. And I see that there are 2 left with no mark. So I have 2 left in the tens place once I'm done subtracting. And then I go into the hundreds place. I see that I have 4 hundreds and I need to take away 2 hundreds. Do I have enough to do that? Yes, I do. I'm going to take away 2. 1, 2. And then as you can see, there are 2 without a slash through. So those are my 2 hundreds that are left over. So I get a difference of 227. Okay, we used partial sums in addition, but you can also use them when you subtract. 4 in the hundreds place would have a value of 400. 8 in the tens place would have a value of 80. 6 in the ones place would have a value of 6. So there's my 486. I am subtracting in this case the value or values that make up 259. A 2 in the hundreds place would be 200. A 5 in the tens place would be 50. And a 9 in the ones place would have a value of 9. Now, I like using partial sums with subtraction because it helps the regrouping make more sense. And here's what I mean by that. I can see I have 6 and I need to take away 9. Well, you can't do that. So you would have to regroup with the tens place. This shows that you're actually borrowing 10. So instead of 80, because I'm borrowing 10 of these, I'm going to have 70. That 10 that I am taking away, I'm just going to put in the tens place because I'm borrowing 110. 110 equals 10. And since we just borrowed a 10 and there were 6 already there in the ones place, that equals 16. Okay, now if I have 16, can I take away 9? Yes. That would give us a difference of 7. In the tens place, if I have 70, can I take away 50? Yes. That would give me a difference of 20. And then in the hundreds place, if I have 400, do I have enough to take away 200? Yes. And in that case, you would have 200. And then, of course, you would take these partial sums, add them together. That would be 200 plus 20 plus 7, which would give you our correct answer of 227. Sorry. Okay, now for the number line. I wanted to make sure I had enough space to show the number line, so this time I put it lower so that we can actually see all of the jumps that we need to make. So, since we're moving backwards, I'm not starting over here because our number is getting smaller, and we know as we move to the left, our numbers decrease or get smaller. So I put 486 over here because as we subtract, our number is going to get smaller. Can we show subtraction on the number line through jumps? Now, I want to show that I'm subtracting 259. If you remember from the addition video, I could do this or decompose this 259 in multiple different ways, but for time's sake, I'm going to keep it simple. My first jump is going to be a decrease of 200. So if I decrease by 200, that means my hundreds place is decreasing by 2. So instead of 486, I now have 286. So I have my jump of 200. Now let's do our next jump of 50. I'm going to jump 50. Going backwards 50. Notice my arrows are going in the opposite direction. So now my tens place is changing. I still have 200s. But instead of 8 tens, I'm taking away 5 tens. That's going to give me 3 tens. And my ones also stays the same. So that's 236. Okay, now again, as I did with addition, I would get to a friendly number. I know that my last value that I'm taking away is 9. I can see I'm at 236, so I'm just going to go ahead and take away 6 to get that friendly number of 230. Right now I have 256, so I need 3 more to complete my taking away of 259. So I'm going to take away 3 more. And that, of course, will give me my difference of 227. My 259, my taking away, is shown right here. When we combine all the values that have been taken away, that represents the subtraction of 259. Okay, now for the next box. The next box says go the distance to find the difference. As we all know, many kids struggle with regrouping. If you have children who struggle with this, you can use different numbers to find the difference. And here's what I mean by that. I can find a number that actually works to where I don't have to regroup, meaning bigger numbers on top and the lower numbers are on the bottom. If I just add 1 to this, that changes this number to 487. But whatever I do to the first number, I have to do to the second number. So if I added 1 there because I want to keep that same distance and find the difference, I'm going to do the same to the 259. So if I add 1 to 259, that gives me 260. Now I have all 3 places with digits that are bigger on top. Therefore, I don't have to regroup. 7 minus 0 is 7. 8 minus 6 is 2. And 4 minus 2 is 2. So if you go the same distance with both numbers, and then you find digits that are all bigger on top and smaller on the bottom, you can do subtraction without regrouping. But this is a great way, as long as you keep that distance the same, you can still find the difference without regrouping. And then, of course, our last box, the way we learned, the algorithm. Notice that the way I set this up, I have each place separated so that I can clearly see the regrouping take place. If I have 6, I cannot subtract 9 because I don't have enough, so I'm going to have to regroup. That means the 8 tens are now 7 tens because I'm borrowing 1 10 so that I have enough. And then what I do is draw an arrow to show that regrouping. And notice anything that changes, I also make a little bit darker than the other numbers. That way I can make sure that I'm using the correct information in solving. So if I have 16, now I can take away 9. That has a difference of 7. Going into the tens place, I have 7 tens now, and I need to take away 5. I do have enough. That's going to leave me with 2 tens. And then in the hundreds place, I have 4 hundreds, and I need to take away 2 hundreds. And I can, so that's going to leave me with 2 hundreds. Okay, all in all, these are all the ways that we can subtract 2 numbers and find their difference. Let me know what you guys think in the comments. Stay tuned for move number 3, which is going to be multiplication.